For hot tub wiring, adhering to the National Electrical Code, or NEC, is crucial for safe and reliable operation. The initial question revolves around selecting the appropriate wire size for a 240-volt, 60-amp GFCI protected circuit, along with understanding the manufacturer's instructions regarding wire size reduction. Firstly, determining the correct temperature rating is paramount. In this specific application, the 60 degrees Celsius column in NEC Table 310.16 must be used for wire sizing. This requirement stems from the fact that a hot tub is considered a continuous load. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. The NEC mandates that overcurrent devices and conductors for continuous loads be rated for 125% of the continuous load, meaning sizing up to account for heat generated. Using the 60 degrees Celsius column of Table 310.16, the minimum required wire size for 60 amp circuit is number 4 copper wire. While THHN insulation is mentioned, it's essential to understand that THHN wire has different ampacity ratings depending on the termination temperature rating. The 60 degrees Celsius rating is the most restrictive and must be followed in this case. Secondly, understanding the manufacturer's instructions regarding wire size reduction is critical. The instructions state that if the wire size is larger than number 6, a junction box must be installed near the hot tub, and the wire size reduced to short lengths of number 8 between the junction box and the hot tub. This practice is permissible under the NEC tap rule. The tap rule allows for the use of smaller conductors to tap into larger conductors, provided certain conditions are met. The primary condition is that the tap conductors must be protected from overcurrent by the upstream overcurrent device. The length of the tap conductors is also limited, depending on the specific application and the overcurrent protection device's rating. The reasoning behind allowing a smaller wire gauge for a short run is that the larger upstream conductors provide sufficient ampacity for the overall circuit. The shorter length of smaller gauge wire is still capable of handling the hot tub's current demand over that limited distance. Here's a detailed breakdown of the wire sizing and installation procedure. 1. Determine the total load of the hot tub. This information should be clearly stated on the hot tub's nameplate. 2. Calculate the ampacity required for the circuit. Since the hot tub is a continuous load, multiply the total load by 1.25 or 125%. This provides the minimum ampacity the conductors must be able to handle. 3. Using NEC Table 310.16, specifically the 60 degrees Celsius column, select the appropriate wire size based on the calculated ampacity. For a 60 amp circuit, number 4 copper wire is required. 4. If using number 4 copper wire, install a junction box near the hot tub. 5. Run the number 4 copper wire from the maintenance disconnect to the junction box. 6. Within the junction box, splice the number 4 copper wire to short lengths of number 8 copper wire. 7. Run the number 8 copper wire from the junction box to the hot tub's connection point. 8. Ensure all connections are made securely and properly insulated. 9. If using number 6 copper wire, no junction box is required. The number 6 copper wire can be run directly from the maintenance disconnect to the hot tub's connection point. Now let's delve deeper into the NEC tap rule and its application in this scenario. The tap rule, specifically section 240.21 in the NEC, outlines the conditions under which smaller conductors can be tapped from larger conductors. One of the most common applications of the tap rule is in motor circuits, where smaller conductors are used to connect the motor to the motor starter. In this case, the tap rule allows for the reduction in wire size from the maintenance disconnect to the hot tub, provided the following conditions are met. Firstly, the tap conductors must have an ampacity of at least 1/3 of the overcurrent protection device protecting the larger conductors. In this case, the overcurrent protection device is a 60 amp breaker. Therefore, the number 8 copper wire used for the tap must have an ampacity of at least 20 amps, which it does. Secondly, the tap conductors must terminate in a single overcurrent protection device rated no more than the ampacity of the tap conductors. In this case, the number 8 copper wire terminates at the hot tub's connection point, which is protected by the 60-amp breaker. Thirdly, tap conductors must not be longer than 25 feet and must be installed in a raceway. In this case, the tap conductors are short lengths of number 8 wire run within the junction box into the hot tub's connection point, meeting the length requirement. It's crucial to consult the latest edition of the NEC for the most up-to-date requirements and specific details of the tap rule. Now let's discuss the importance of using a GFCI breaker for hot tub circuits. A GFCI, or ground fault circuit interrupter, is a device designed to protect against electrical shock. It works by monitoring the current flowing in the circuit and comparing it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip, interrupting the circuit and preventing electrical shock. Hot tubs are particularly susceptible to ground faults due to the presence of water. The NEC requires that all hot tub circuits be protected by a GFCI breaker. This is a critical safety measure that can save lives. When installing the GFCI breaker, follow the manufacturer's instructions carefully. The breaker must be properly grounded and wired correctly to function properly. Test the GFCI breaker regularly to ensure it is working. Most GFCI breakers have a test button that can be used to simulate a ground fault. If the breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to the GFCI breaker, a maintenance disconnect is also required for hot tub circuits. A maintenance disconnect is a switch or breaker that allows the power to the hot tub to be shut off for maintenance or repairs. The disconnect must be readily accessible and located within sight of the hot tub. This allows someone working on the hot tub to easily shut off the power and prevent accidental energization. The maintenance disconnect can be a separate disconnect switch or a breaker in the main electrical panel. If using a breaker in the main panel, it must be clearly labeled as the disconnect for the hot tub. When selecting a location for the maintenance disconnect, consider its accessibility and visibility. It should be located in a place where it can be easily reached and seen from the hot tub. It should also be protected from the elements and accidental damage. Proper grounding is another critical aspect of hot tub wiring. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. The grounding conductor must be sized according to the NEC and connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete-encased electrode. All metal parts of the hot tub, including the motor, pump, and heater, must be bonded together and connected to the grounding system. This ensures that all metal parts are at the same potential, reducing the risk of electrical shock. When running the grounding conductor, avoid sharp bends and kinks. Use appropriate connectors and terminals to ensure a secure connection. Inspect the grounding connections regularly to ensure they are tight and free of corrosion. In summary, wiring a hot tub requires careful attention to detail and adherence to the NEC. Proper wire sizing, GFCI protection, a maintenance disconnect, and grounding are all essential for safe and reliable operation. Always consult the latest edition of the NEC and follow the manufacturer's instructions when installing a hot tub. Consider hiring a qualified electrician to perform the installation to ensure it is done correctly and safely. One last thing to note, aluminum conductors are not mentioned. If aluminum conductors are to be used, different ampacity values apply in NEC Table 310.16. Also, connections with aluminum need to be made with compatible connectors that are rated for aluminum to prevent corrosion from dissimilar metals being connected to one another.